Hello, and thanks for joining us for another video from the Bismarck Weather Education Center. Please enjoy part 2 of our air pressure experiment video series.
We're back, and this is a great experiment on air pressure because we're going to alter air pressure, and what we're going to see is an implosion where the can actually is crushed from the outside moving inward. Now kids, if you're doing this at home, this is a great experiment for school. Always have your parents around and always have your safety goggles because we will be using these quite a bit. Okay, let's set the stage on what's going to happen for this implosion to occur. We talked about air pressure and what comprises there. We talked about the oxygen, the nitrogen, and the water vapor and some other constituents. Well, we have to alter the air pressure inside this can. The way we're going to do it is we're going to take a teaspoon of water, and you can take it right from your bowl, and we're going to go ahead and put it right in the can of soda. And for the sake of time, we already have done that and put the soda can on the hot plate. So what's going to happen is this water is a liquid, of course. It could exist as a solid as ice. It could be liquid like we have it. But we want to change the phase from a liquid to a gas. And by doing that, as we add heat, the only thing that's going to be left in this can is the gas, the water vapor. Right now we have the oxygen and the nitrogen, but we're going to force that air out as we go through this phase change. So in defining what's happening here, we have to look at temperature. Temperature is defined by the average motion of air molecules. If we heat the air, those air molecules, in this case water vapor molecules, are moving around very, very quickly. When we cool the air, they slow down. So in essence, we're going to really have these water vapor molecules moving very quickly. It's pushing the air out. Then, after we have a gas in here, we're going to quickly turn that soda can into this very cold bowl of water. What happens in the morning, on a summer morning, when you walk outside and you touch the grass? There is dew on there. Well, that's what's going to happen in the can. We're going to cool the air to what we call its dew point, which means all that gas, that water vapor, is going to condense into a water droplet. It's not going to occupy a very big space in the can. It may occupy one little space on side of the can, one droplet. The rest of the air inside of the can, there will be none. There will be empty space. We call that a vacuum because everything was forced out. So if there's a vacuum in there and we still have this 14.7 pounds per square inch pressing on the can, it should implode. And that's what we're going to see. Let the can heat up with the water until you can see a little cloud forming on top of the can. This is the water vapor from the air, from the water itself in the gaseous phase interacting with the cooler air outside the can. Let it go for about 30 seconds and then the whole can is filled with nothing but a gas. We're going to quickly take this can and flip it into the cold bowl of water. Watch what happens. There you go. The force of the air pressure outside of the can forces the water up inside the can, and that's why you end up with water. So that is the power of air pressure, and this is what, it's very cold now, but this is what it can do. Amazing.
It's a good one.